This is the second video on the lesson one. We'll talk about poles and zeros and how it's being utilized in first and second order impulse and step responses. And so let's talk about first order first. Okay, for first order impulse responses, the transfer function is 1 over s plus a. Okay, so for its impulse response, okay, impulse response means what? You have to multiply an impulse input to a transfer function. Okay, so from our relationship over here, you know that the transfer function itself, g of s, is equals to l of s divided by u of s. Right? This is the output, this is the input. So therefore, if you were to bring this up here, you have input times transfer function, and this input is a step response in this case. So step input in this case is actually one. So one times the transfer function is actually the transfer function itself, and therefore the output is the transfer function itself. So this is why we have this dude over here, 1 over s plus a. So it's like an invisible times 1. The 1 is the is the impulse input. So if you were to do a Laplace transform, invert Laplace transform, inverse plus, you know what I mean, okay. So you'll get, in the time domain, is e minus at, okay. So if you don't believe me, I'll just show you. So 1 over s plus a is where am I? 1 over s plus a is e minus at. Okay, this is the, you know what I mean already, so I just don't talk about it anymore. So yeah, so this is an exponential decay graph. Okay, simply say that if we have a graph over here, it starts from here and then it starts to decay exponentially. This is what it's talking about. And then the starting value at time t is equals to 0. Okay, at time t equals to 0 is 1. Okay, at time t equals to 0 it is 1. And then when it goes to infinity, it is eventually will dies down, it will decay to 0. Okay, so this is what it's talking about. And then for step response, okay, step response and impulse response, make sure you know the difference. Okay, so impulse input is 1, step input is 1 over s. So in this case, this is why we multiply a over s plus a times 1 over s. Okay, so we have a multiply. So we will have 1 over s. So if you have this thing, definitely you have to do partial fraction, or perhaps the cover up rule. Eventually you will get this thing. Okay, this is just this one. Okay, I'm not going to cheat your feeling. So this is it. And then you can rewrite your step your response back into the time domain. Okay, so 1 over s, your inverse is 1. Okay, so it's minus 80. So in this case, the graph is exponentially going upwards. Okay, so no, sorry, hold on. Okay, it should be going like this. Okay, towards 1. Okay, so its final value, it should be at 1. Okay, at first is 1 minus, at time 0, e to the power of 0 is 1, right? So this is 0, and therefore when you start to increase the amount of time, okay, this thing will start to go up, may eventually reach 0. Okay, I mean eventually reach 1. Okay, near 1. Okay, because this will never become 0. It can be very very small value, maybe 0.0000005, and then 1 minus this one is nearly to 1. So I hope you get what I mean. So just to, it's a partial summary. So we have talked about impulse response and step response, and how impulse response means that you induce an impulse input into a transfer function. You input a step input into a transfer function. As you can see, the transfer function wise is a little different. This is a over a s plus a. This is 1 over s plus a. Okay, so it's a little slightly different. Okay, make sure you know the difference. Okay, if you ask me why you want to include an a over here, is just a constant. Okay, it's just a constant. So 1 is also a constant, just that a itself it's yeah whatever. Okay, anyway, so let's after knowing this after knowing first order, this is first order. Okay, this what I've been talking about is all about first order. So the poles of the first order system, if you remember, what is pole? Pole is whatever thing that makes the denominator 0 or makes the whole equation becomes infinity, it's pole, right? So in this case it's A of S. So this we are talking about a transfer function. So whatever thing that makes the transfer function becomes infinity is pole. So for our step for our okay what we are talking about. Okay. So for example for let's say step input. Okay, so hold on a while. So whatever thing that makes the transfer function g of s to becomes infinity. So what makes this becomes infinity? Okay, the only way to make this infinity is that s is minus a, right? But s is equal to minus a, and therefore, hold on, and therefore, when you plot it in the plot itself, okay, this is the real axis, this is the imaginary axis, this is the Argand diagram, if I'm not wrong, okay, but this real axis is in terms of s, okay, so whatever s that you have found, so in this case it's minus a, so there's something minus a over here. So this is your pose. Pose when you're pose, okay, pose. So when you're talking about pose, the signal, the label itself is actually a cross. It's saying that okay, infinity, no, okay, so something like that. So if it's a 0, then it will be a circle over here. Over here or here, whatever you want, okay. In the future, then we'll talk about it. So in this case, pose is actually a cross. And you may wonder, so therefore this is only one, there will be only one pose in this case, okay, one pole. So what if we want two poles, okay, two poles, let's say the transfer function now is s plus a, and maybe s plus 2a. So what makes this transfer function? So I repeat again, this whole thing, when you're taking poles and 0, you're taking the transfer function itself, okay, please, the transfer function itself. So in order to make this 0 is minus a, right? Okay, minus a plus a is 0. So the whole equation will become infinity. Another one is that this is s is equals to minus 2a. So in this case, there is two poles that makes the equation 0. So therefore, this is minus 2a. Okay, makes the equation infinity. Makes the equation becomes infinity. So these are the two poles that makes the equation becomes infinity. And also the other thing I'll let you know, okay, before I go to the page itself, is that this portion is considered stable. Whatever s, okay, whatever value of s is at this portion over here, at this shaded in red portion, we say that this thing are unstable. This poles or these zeros are unstable. So we try to dodge this area. If you are in this area, you try to put some new function. Let's say if you have some poles over here, and then you make sure you put in some new equation, making sure that this poles will switch back to here, and then will eventually come to here. Later in the future, I'll talk about it. So therefore, this sets the 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 first part for poles and zeros utilized in first order step and impulse. Okay, step or impulse things. Actually, I haven't finished yet. So this is only for what do we say, the transfer function for the response, for step response. As you can see, it's over here. It's for the impulse response, sorry. So for impulse response is 1 over s plus a. So what if it's step response? Okay, we have a over there. Okay, yeah. In fact, a, okay, in fact is whatever s that make it 0. So do you see any s in this numerator? Okay, no. Okay, if there is s, if let's say our transfer function in this case is this. Okay, so if this is 0, then everything will become 0. So therefore S is actually 0, which is this portion over here. Okay, so the value of S is just 0. If it's, let's say, numerator is S minus A, maybe S plus A, okay, and maybe this is S plus 2A. Okay, what are you gonna do? So just spotting out is just saying that whatever thing that makes the numerator 0 is called zeros, right? So minus A makes this thing equals to 0. So when you plot in this Argand diagram, your 0 is actually this. So you draw a circle. So for the denominator, if it's making it 0 for the denominator, we call it poles, right? So you just plot minus 2a as a cross. So as you can see, this is the zeros and this is the poles. Okay, so you make sure you need to know how and when and what are the poles and zeros. And the next video I'll talk about the second order. Okay, second order impulse and set responses. I hope I made this clear for poles and zeros.